Good afternoon, everybody. Thank you for joining us. Bear with me, I'm pulling up my notes as we speak. We are going to be talking today about low latency and the future of video transport, and I am getting my notes here. I want to get this right. So, I should have had this up. There we go. Okay. Clicker in hand. I am good to go. So if you're editing this, you probably want to start this right now. The future of video transport. Flash RTMP, easiest time I ever did. Did anyone see the movie Shawshank Redemption? That's like my favorite movie, right? He has some guy, easiest time I ever did. Well, Flash is in jail. They say Flash is dead, right? There's like the rest in peace, and there's the gravestone for Flash. Well, I think Flash is actually in jail, and Google is the jailer. Because Flash was pretty awesome. And yes, I'm one of the people that are angry that Flash went away. So today we're going to be talking about low latency. And we have a wonderful panel here. And I would like to ask each one of them to please introduce themselves. Go with Kristie.
All right. My name is Kristie D'Ambrosio-Correll. I'm the VP of Engineering and Product at Mirror. Mirror is a at-home fitness platform. We're a hardware company here in New York, and we stream live and on-demand classes as well as personal training sessions to our customers across the country.
Next, please.
Great. Yeah. Hi, everybody. I'm Oliver Gunasekara. I'm CEO and co-founder of NGCodec. We do video encoding in the cloud, but what's unique about us is that we don't use CPUs. We use programmable hardware, FPGAs.
And I'm Richard Oesterreicher. I'm the CEO of Streaming Global. We're a technology company that solves the three major pain points for OTT and video on demand, one of which is performance over transport.
Cool. Well, one thing we're going to be addressing this morning is low latency. This afternoon, thank you, jet lag. And there's some aspects of the low latency component. One is the best practices. The other would be the real world application. Within best practices, there's encoding. But also at the same time, how did we get here? How did we get here with the need for low latency? I remember, with older streaming protocols, that it was much easier to get video out near real time because we were dealing with RTSP or RTMP. I think I did my first video stream in 1999 with like Real Server. So it seemed like it was much more now, back in the earlier days. I was curious if anyone on the panel had any context on just where we've been versus where we are today with regarding low latency distribution.
I'm happy to jump in there if you guys would like. My first stream was actually at Microsoft, and this is before Windows NT shipped. So it was the early days. And back then it was not easy to move data through the public internet. The internet was designed for very small, very static content. And so video definitely was the opposite in every category. So we had to make a lot of architectural choices in those early days to solve problems for what the internet was. This is before broadband was ubiquitous, so you had to have adaptive bit rate just to get out there to the server, much less the last mile, which is where ABR is really used today. And in addition to that, you had to do a lot of processing at the server or ahead of time because every device needed a different resolution or a different format. It was really kind of the Wild West for streaming in the 90s. And the architecture didn't really change a lot over the next, say, 20 years, which is how we ended up with latency issues, whereas the internet's changed dramatically over those 20 years. So now is the time to be talking about what we can deliver.
Interesting. I'm curious if better performing networks, better performing devices really play into how we're distributing today. Like we think about yesteryear when the DSL. This is way yesteryear when DSL in the home was still kind of a new thing, and then we started with really slow internet connections. But now we have like 5G, super fast. You know, the internet here, if you're plugged in, it's like 1 millisecond latency. So I'm just kind of curious, in your experience, anyone on the panel can answer this. How are these faster performing networks helping?
I can have a go at that. I mean, they're definitely helping. As you said, the pipes have got a lot faster, a lot higher quality. You know, some parts of the world now has fiber quite widely deployed to the home, and that's what's really giving you these type of latencies. I'm sure the hotel has fiber. But you know, what we need to counter that is that our experience has also gone up drastically. No longer are the majority of people watching SD. We're watching HD and beginning to watch UHD. We want high frame rate in some cases. We want HDR. We want 360. And so all of this is then kind of pulling back the experience. And so it's still very, very challenging to deliver live video with high quality.
Okay. Any other comments on network performance?
Yeah, I'd be happy to jump in there too. We at Streaming Global have been focused on what can we do. Eventually we got frustrated with the fact that the architecture hadn't changed so much in the last 20 years, and we just took a clean sheet of paper to it. We decided we were going to reimagine how would we architect streaming for today's internet as opposed to the one that everyone's continued to use since the 90s. And by doing that, we were able to eliminate a lot of wasteful pieces in the middle, in the server side. And to your question about device capabilities, both the source devices and the viewing devices have gotten a lot more powerful in that 20 years. So when we looked at the architecture, we moved some of that functionality to the left to where the source is, the encoder and the packager. And then we moved some of the stream out services to the viewer and turned it into a pull model instead of a push model, since it already has all the data on what its performance is, what its connection is. By doing that, all we were left with in the middle was cloud storage. And by doing that, we were able to significantly reduce the overall pipeline cost for delivering the content while also reducing the performance. If you've got encoders like NGCodec has available to you, you're going to get sub-second delivery over the open internet today with that kind of an architecture. And we actually did a test last week, public test in Atlanta, where it came in at 0.6 seconds end-to-end through a data center in another city. We've been doing demos just in the hallway, on the floor here at this show. Our server is still in Atlanta. We're in New York City, and I think yesterday it was 0.9 seconds end-to-end live latency. So obviously vastly faster than the rest of the industry, and it's definitely possible to do today.
So on that note, it sounds to me like you're putting more horsepower on the encoding side and a little more horsepower on the device side. One thing I've noticed, I don't know if you guys have ever watched HQ Trivia. It's powered by an ultra-low latency platform, Wowza, to be sure. And I've noticed it burns my device CPU like crazy. And I would assume that it's that type of approach where you're enjoying this low latency content, you're participating in it, but your phone's getting really hot. I don't know if this sounds familiar or not, but it's remarkable to me how much power is in our hand. And I would assume that something similar is happening on the encoding side.
It's probably the GPU that's heating up, because the hardware encoder is probably taking advantage of the GPU in a mobile device.
Yeah, and I think my takeaway on that is it's kind of exciting that you're not just putting the TS files out there, you're not just streaming just a standard HTTP, which is pretty easy for a device to do, but you're actually leveraging some serious resources. I'm glad we got to cover that. Do the new devices help by chance? Like the new iPhone X, the newer, more capable devices, does this actually help with the low latency, with the actual play out? Or is it still pretty universal on which devices play?
We're definitely seeing a difference in performance with the newer devices that have more cores in them. We're taking advantage of it. Our encoding and our packaging is multi-threaded to get as much out of the device as possible. We definitely take advantage of the API that's using their GPU so that we're burning the minimum amount of battery required to be able to deliver a live stream. But yeah, definitely everything in that little tiny box we're going to take advantage of.
That's super exciting. To the audience, raise your hand if you've tested a ultra low latency platform before, or used one, I should say. Cool. It's an interesting experience, testing low latency. Now, I also think about, and I'm directing this at Kristie, business. You know, here we are, a bunch of propeller head guys playing with encoders, playing with networks, doing tests, showing off wares. But you actually have a business that you operate.
Correct.
Running an ultra low latency experience.
Correct.
I'm curious, what was that discovery process like for you as far as making sure that you found something that was affordable, that worked, that met some of your needs? Just any comments on what that was like for you?
Yeah, I mean, I'll be honest, affordability was kind of the last part of the equation, just because we knew that we had to deliver a real workout experience to the end user that was going to feel like they had an instructor in the room with them at the time. And so we had to be able to provide an ultra low latency experience, and that was critical to our platform. We did a lot of testing of different platforms. We've obviously landed on Wowza, which I mentioned to you. And at the end of the day, we are still testing and we are still refining that process. So we're not quite where we want to be, but cost honestly went out the window when we knew that it had to be a perfect experience for the end user.
Wow, that's amazing. So cost went out the window. You need to write that down. This is a real business person who actually used the words together in one sentence. Cost went out the window. That's amazing. And as I understand it, you have an app, an experience where people can actually work out with a trainer or participate in a real live workout scenario.
Yeah, and it's not app content. It is our own device, so we have our own hardware that's installed in your home. We're not app-only content at the moment, so we're actually not utilizing an Apple device. We're utilizing our own device, and so we did have some ability there to sort of leverage more cores and use a better piece of hardware that we knew was going to deliver the experience we wanted.
Thank you for qualifying that it's not an app, but it's actually a full experience, which is probably much more immersing than holding onto a device. Yeah. I know, in working with low latency, you've obviously tested it. You have to figure out how this thing works. I've done demonstrations with our product, and I've struggled because I don't know how to encode properly for ultra low latency. And I found, someone actually handed me a set of settings, and I'm going to get to Oliver on this one, but someone handed me some settings that were optimal for OBS to go into our ultra low latency environment. I'm curious, what are some of like the specific, when you're dealing with codecs, the frame rate, keyframe intervals, bit rates, what's a good approach? And Oliver, I hope you can help us out with this, is I'm going to do low latency, how do I stream it?
Yeah, I mean, I think fundamentally you have to understand that, an encoder, no matter who you use, is looking for redundancy. And so the more frames of video that it can look at, i.e. the higher the latency, the better the job it can do for compression. So every encoder will have a trade-off. The lower you push that latency down, the less compression efficiency or the higher bit rate you will need for a given visual quality. And so that's a trade-off. That being said, there are specific techniques that you can do to get latency down further and further. You can play with the keyframe interval. That has a big impact in HTTP style streaming, Dash or HLS. But you can also adjust features like not using B-frames. Again, that will affect your latency, but if you really want to get the latency to be absolutely as low as possible, then you do need to switch off these settings. And nearly every encoder vendor will have some presets or some settings where you can say what type of latency you're after. If you want to go the absolute lowest latency, we have a product, well, it's not really a product, we have a proof of concept over 5G where we're doing sub-frame latencies. So we're doing sub 10 milliseconds. Now that needs substantially higher bit rates, but it does allow fully interactive computer type experiences, in this case of VR, where you can put on a pair of VR headsets and the computing that's rendering that graphics is actually geographically remote.
What kind of bit rates are you talking about?
So in that design, we're effectively, the pixel rate is effectively 4K. It's running at 90 frames a second, and we were streaming it at about 20 megabits. So, you know, quite a bit higher than if you were having, say, a second of latency, which is kind of normal for a traditional Dash or HLS use case, where we might, for the same quality, might have needed about half that bit rate or less.
Thank you, that's fascinating. Richard, I'm curious if you have any tips on encoding best practices as well, anything you're thinking while Oliver was speaking?
I'm just wowed by Oliver's proof of concept product. Subframe encoding, where he's slicing the picture, is just, yeah, I'm really excited to talk with Oliver after the panel.
Kristie, what have you learned in this low latency real life business of yours? What are some things that might have gone wrong? What are some takeaways? Anything you might want to share with us? That it'd be interesting to know some of the challenges you've had in getting where you are. And if there aren't any challenges, I'll be super impressed, because this is video, folks. Any comments?
Yeah, I mean, I think, you know, just like anything else, it takes tuning, it takes sort of refinement, it takes testing. And so we went through a lot of that. But I think one of the biggest things that we've struggled with and we're continuing to struggle with is sort of not only the incorporation of low latency video, but also low latency data. And so we have sort of dual streams coming into a workout. One is our video and the other is real-time data, and sort of keeping those together is really important. So we've been able to do a lot of refinement on the video side, but we have not been able to do the same sort of on the data side. And so that's been one of our biggest struggles, is sort of to some degree almost having to like slow down the video to sort of make sure that it always matches up with our data stream. Yeah.
We had a customer early on that had a similar problem. They were doing live auctions, and their data was falling behind. And so we modified our architecture to actually embed the data in the video stream. And I think it's a good requirement, definitely a bullet point item for the future of video transport. If you can't synchronize data, you're missing out on too many opportunities. So that's what we did with our design. And at this point now, we have data and video just completely in sync, and it stays that way.
So you've got data in the pipe.
As part of the transport, yeah.
Does that open up opportunities to do other things besides video with it? I know that's kind of a crazy question, but can you do other things besides video with this architecture?
Certainly.
And what do you think about that, Richard? Tell us.
There's a little notebook I have back at the office on things we're going to be doing for our growth plans.
It sounds very, very secret.
It is. Yeah.
Can you give us a little, like...
Well, there's a lot of different areas where low latency matters a lot, that it's more important than Netflix. Being able to watch Netflix at home, latency is not as important as live sports or the things that go with live sports. Ever since the Supreme Court ruling here in the United States a couple of years ago, where every state gets to now choose when it decides to allow sports betting. Technology's got to catch up a little bit on that, because synchronization becomes extremely important. Another important bullet item for the future of video transport topic. So while latency is significantly the most important part of that, being able to synchronize viewers without having to drop down to the lowest common denominator on who's watching something really opens up a lot of different business opportunities, and almost all of those require the ability to have data in sync with the viewing.
Yeah, and I would add that, you know, there is kind of some of that done today, because nearly every video stream has audio, and you do need to synchronize the audio to video, otherwise you have lip sync issues and it looks pretty bad, and there is normally a timestamp.
Yeah, just the presentation timestamp.
Exactly, yeah. Which is a technique that's used. So I think there are pretty well-known techniques that can be used to apply to additionally not just audio but other type of data that you want to synchronize.
When we started to get really low on latency in tests, before we even started to show it to people, we realized we needed a better way to measure latency. We went well beyond the stopwatch and watching somebody's hand move on a video stream, which is how we started, but that was the low-tech solution. We decided, well, we've already got synchronized data. We just created a new MP4 box for an origin timestamp and embedded it right into the stream. So anytime we're picking up a chunk or fragment, we have all the data we need to measure when did it leave the origin. So glass to glass, every single step that stream took before the encoder to being viewed after the decoder, we know exactly in ticks how long it took.
Okay. That's awesome. That is a lot better than the hand-waving video
It
with
is,
the WebMTC player in the browser, right? I'm thinking about something, and I'm wondering if I'm wrong. I might be wrong, but I'm looking at CMAF, which ultimately provides, I don't think CMAF gets into your sub 1 second world or your sub 2 second world. My opinion on CMAF is when it becomes available through CDNs, it'll probably be in that 2 to 6 second range. And there's a lot of work to be done to get there. But I'm thinking about low latency in 2 different ways. Like a CDN can probably learn to scale CMAF using HTTP. And then there's the low latency, what I see as cutting edge, what you have described, what a lot of our companies have built is a very ultra low latency platform. And there's a lot of healthy competition there. Do you gentlemen think that there will always be a special scaled distribution for ultra low latency, and then that there probably would be a little more of a commodity-based distribution to scale for something like CMAF? I'm looking for hints on scale. Oliver, you
Maybe we could put up the diagram
Sure.
and kind of, this was something that I created. Maybe it will come up.
Let me get to the presentation.
Yeah.
Yes.
So this was my attempt to try and map the landscape for distribution. I'm not talking about contribution, SRT or RTMP. I really tried to focus on you're running at scale and you want to deliver video to consumers. And today we know the norm is really traditional ABR, HLS being the dominant and dash. But the latency is around the 20 seconds. It can go higher. That is kind of the norm today out there. And if you look at linear TV, obviously that's driven over a cable network or a satellite network. It's around 7 seconds. And so that's a big problem, because if your neighbors are watching the sports game and you're streaming it, they're going to be cheering way before you know about it. And so there's immense pressure to get OTT to being below 7 seconds, to being below linear. And that's where there's a lot of activity now in CMAF and chunked. And a lot of people are beginning to do that on Dash. HLS, it's coming. There's some proposals for the low latency HLS. Let's see what Apple does at their developer conference in a month's time. Hopefully we're optimistic that it will be formally standardized. But that can get you, with a lot of work, to around 3 seconds. And you can see people like Twitch are already doing this. Now Twitch has an advantage that they control their complete environment, from their CDNs for ingest, their encoding infrastructure, their CDNs to deliver, and their client. But they are now getting, in low latency, sub 3 seconds, which is pretty impressive. But I think we're going to see a lot of the industry moving into that area to below linear. And then you come to what I would call ultra low latency, and I've kind of defined it here in 3 areas. There's the 500 milliseconds, because there are many applications that people have talked about, sports betting, etc., where 500 milliseconds is really good for communication, for interactivity, and WebRTC is gaining in traction on top of that. Then there is cloud gaming, where you really want to be around 60 milliseconds, because otherwise there's a bit too much lag. And then the further extreme is what we call Cloud XR, where you might have a head-mounted display, and as you move your head, you want it to update. And ideally here, you want to be sub 20 milliseconds. And so my feeling, going back to your original question, is that I think we will move to these standards, WebRTC, Dash, low latency, HLS, all but the sub 60 millisecond applications.
Thank you.
I'd like to jump
Yes.
in on that question too, if you
Please.
don't mind.
Please.
Specifically about, will there always be a different approach on that ultra low latency model? And I think that one of the things I love about technology, other than being able to wake up and dream about innovation every day, is that there's always room for improvement on every technology. It always gets replaced eventually. There's always a better way, or something else in the ecosystem changes that you can take advantage of. So by thinking about it that way, I think there'll always be a new protocol or a new technology that will push the limits on how fast we can go. And Oliver did a great job of explaining some business models that require that. To be able to do cloud XR headsets, if you want to avoid, it's not just about latency. At that point, it's about sickness. when you're turning your head, if you're an XR fan, you know exactly what I'm talking about already. But being able to do remote rendering that can be delivered in less than 20 milliseconds is just a whole different world. And so there's a lot of innovation yet to happen with that type of transport. In addition to the encoding work that he's already doing, which is sub 10 milliseconds, at that point you've got to get it on a transport. And right now we're still dealing with, 5G's not here yet, not really. So we're still dealing with cellular networks where it's not just the bandwidth, but it's the jitter. If you're going over 4G LTE, you might have 50 milliseconds, you might have 400 milliseconds of jitter. You don't know until you're pushing that content, which can have a significant impact on latency that is just completely outside of your control. 5G hopefully won't just improve bandwidth, but will really improve the network jitter and make it look more and feel more like a Wi-Fi or a wireless or a wired network. If we can get to that point, that just blows the doors open on business and its ability to take advantage of low latency.
Thank you, Richard. I have another question for the panel, but we are going to open this up for questions. So I would encourage any of you who are keenly interested in this topic to get your questions ready. But I do want to ask this group, and this is what I'm observing. Each one of you seem to have a really good grasp on what you're doing. We have technologists and we have an entrepreneur business person here. I'd like to know, it's a question you can, what was that? Was that feedback? Excuse me. It's a question you can ask a couple different ways. I would say, what are you either dreaming about? What would you love to see happen technology-wise in your business or in your sphere, that your ecosystem where you're working or innovating? Or if you had a blank canvas, how would you engineer where streaming is today? And in the context of ULL and some of what we've talked about today, just going forward, what would be something that would excite you?
Let me have a go at that, because I'm really passionate about this. I'm a long-term mobile guy. It's what I did for the first 20 years of my career or so, and saw the first generation smartphones. And I'm kind of now ready for the next phase. We've had smartphones, for over a decade. So the question is, what comes next? And I'm pretty convinced that what comes next is going to be streaming. So what do I mean by that? I mean smart glasses. I mean what we call cloud XR on this graph. The idea that in 5 to 10 years from now, I don't think we will be having smartphones. I think they will have gone the way of pagers. I think most people are going to be wearing smart glasses where all of that heavy lifting is going to be at an edge server, and streamed over 5G will be the pixels. And what will those pixels do? They will give us immense information, entertainment, and they'll even provide additional people. There'll be people that will attend this conference. Here's a prediction. 10 years from now, there'll be people here that will actually not be here, but they'll have almost the same experience. And we will see them. So right now, there could be people on the live video feed, but we don't get to see them. We just see the camera. But imagine in the future, they could be sitting in these virtual seats, and with our glasses, we actually see them and interact. I absolutely believe that that is going to come, and I can't wait for it.
That's exciting. What are you thinking, Richard?
I think, I'm hoping Oliver's right first. But I think that the things that opens up for the experience of not just online shopping, but retail and the way it's going to change everyday tasks that you do, to have the ability to combine real-time computer graphics that are believable with real-time rendering, with basically what becomes real-time encoding and real-time delivery of that to a device that you're wearing. Yeah, as long as you're going to have to send a little bit of data back the other way too, to be able to track and obviously then mimic the exact camera of where your eyes are looking. Once you combine those few things together, and every one of those is hard to do, but once you do, it changes the way humans communicate on a really large scale. It can lower energy usage on flights across the planet. It can change the way you do customer service or sales for every single order. It can have a really large impact on how we live our lives.
Wow, very exciting. And Kristie, you're sitting with a couple technologies. What are you dreaming about? What do you think? What are you thinking?
Yeah, I mean, this is obviously something we think about on a daily basis. And I think to sort of build on what you were saying, Oliver, it's not only just what you wear, but also what you experience around you. And so I think Mirror, sort of a good example of where we're headed, but sort of immersive content, immersive technology that lives around you, on you, potentially in you. That's sort of where we're headed. And so this is something we think about, how do we deliver not only right now it's fitness, obviously we're thinking of other verticals that are possible on our kind of platform, but as are most companies, which is how do you deliver things like shopping, things like healthcare, things like streaming events, how do you deliver that in a way that is truly like you're there? And I think that's definitely where we're headed.
Well, I would be keenly interested in some questions from the audience. I think we've covered some very exciting technology concepts here. We've talked about encoding. We've talked about some different ways to transport ultra-low latency. Anybody have any questions? Gentleman right here.
Question for Richard. I was in a presentation earlier and they mentioned that they utilize WebRTC and a dedicated infrastructure for latency of 2 to 3 seconds. And I think you mentioned 0.9, so what's the difference?
So real quick, the question is WebRTC latency 2 to 3 seconds versus 0.9 and what the difference is. I need to repeat the question so it gets into the recording.
Sure. I'll talk as best I can to WebRTC. We don't use that particular technology for live streaming for reasons of scalability. We wanted to create something that could be used for Super Bowl size audiences. So reliability at scale was an important part of our design criteria when we started with that blank piece of paper. So we actually stepped back from custom protocols, from nothing peer-to-peer related, and specifically we deliver our video streams over straight standard HTTP. Which is different than HLS, even though they both use HTTP. Ours is such a different architecture, it's just a whole lot faster. Did that answer your question? Thank you.
Any other questions? Yes?
Hi, to the panel. Basically, I'm interested or asking hybrid solution for delivery. For example, multicast/HLS. You still stay with the existing equipment, encoding, packaging, and you change the backbone to UDP, multicast, whatever, and then you back. But then the edge with some kind of proxy, still HLS. How do you see those solutions? Even though I'm going to a satellite in between, bi-directional via satellite. So this kind of solution, how do you see that?
So the question is a hybrid solution. How do you see the infrastructure on the conventional delivery versus the dynamics of the ultra-low latency?
I'm happy to jump into that one too. The number one difference you're going to see is cost. And I think there's going to be, it's already begun, there's a big shift right now going from satellite for contribution to actual streaming for contribution. And the real driver in that is just the cost comparison in delivering something over, even securely, over the open internet versus having to rent time on satellites. You also mentioned multicast, which is you know, it was a fantastic technology in the late 90s, early 2000s that a lot of streaming providers experimented with. But UDP, which is what multicast was based on at the time for networking delivery, just proved too unreliable for what the internet was at that time. I think that multicast definitely has uses where it can be very beneficial. I think if you look at the model, one of the things that I heard last night on the Stream Media Advanced Forum podcast that they were recording live here at the conference, the #1 transport for reliability has and always will be at the moment broadcast. RF delivery works at scales that nothing touches yet. So if you think about it that way, that's really kind of the ultimate multicast without all the networking interference and peering points that slow it down. I think there's something to be learned by that, and I think that it might have something to do with future technologies that will continue to improve this.
Yes, sir.
All three of you expressed the future of low latency interactive services that, like Richard said, Oliver, we all hope is correct. But it requires you to build edge networks to supply that. Who's going to build those networks? Is it going to be the cloud providers or the CDNs or someone we don't know about?
So the open question is, we're talking about low latency, and we're talking about specifically edge networks, and who's going to build those edge networks to get that data out? Oliver?
Yeah. So you're absolutely right. I mean, as you push the latency, the speed of light issue comes up, and you know, it's effectively for every 60 miles round trip, it's about 1 millisecond. Speed of light is about twice that, but then there's overhead to go through equipment, and it obviously does depend how many hops and how many pieces of equipment. But it's the simple number is 1 millisecond every 60 miles or 100 kilometers. So if you really want to push the type of cloud XR services I'm talking about, where your total budget is 20 milliseconds, and that's everything, you need to be within 60 to 200 miles location, which means an edge server for each metropolitan area. So your question of who's going to build it, I believe ultimately it's going to be network operators. I think people like AT&T and Verizon will see this as a killer use case for 5G, and to utilize it, they will have to invest in edge servers in major metropolitan areas to deliver these types of services. But you know, it could be a Google or an Apple or an AWS could also step up.
Excellent. Any other questions? Yes?
You mentioned about HQ Trivia app, and that's probably one of the great use cases of ultra low latency right now. And you said that they're a Wowza client. I'm just letting everybody know I'm not being paid to ask this question of Tim, but can you talk about what Wowza is doing for ultra low latency and how that's achieved?
Sure. Yeah, the question is, I had anecdotally mentioned HQ Trivia, and that is powered by Wowza Media Systems. It's achieved through a ultra low latency CDN. So essentially, we have deployed our technology, our edge, we call it like an ingress, midgress, and then egress. And we're essentially using our streaming engine software to distribute it through servers that are hosted globally. And I believe they're hosted in Microsoft Azure. So you know, I don't think that is proprietary, but essentially that's how it works. It's a conventional encoder, goes in RTMP, and we just get it out there fastest through WebSockets. And then it's able to be played back in an SDK on a device that's compatible with the low latency protocol. And it of course also works through a browser like Chrome. If necessary. That's a high level. If you want more detail on that, I'm happy to. In fact, I have some colleagues here with me here as well. We'd love to give you the download on that, but that's how it's done.
And one more question. So a lot of our clients are really concerned about end-to-end encryption, and so looking at Zixi, SRT, some of those, how does that impact delivery of ultra low latency, or does it not? So
the question is end-to-end encryption using something like Zixi or SRT. It's basically the security layer for ULL.
Yeah. Well, one of the things I'm seeing right now is just like on SSL, just for standard network traffic, became hardware accelerated once it became popular. I'm seeing companies like one, we're actually partnering with one right now that created a hardware acceleration board for storage servers. And it picks up all the heavy lifting of not just the network and the, what's necessary for increasing IOPS and scalability, but it's also able to run encryption software in reconfigurable hardware. So it's running at electron speeds and without having to tax the actual storage server. And I think that you're going to see more edge networks as they adapt use this kind of hardware acceleration for exactly that kind of reason, because there's going to be a lot of processor intensive tasks that are going to be dynamic. They're going to change over time with the market. And you need to have that flexibility to be able to hardware accelerate that without waiting for the next CPU cycle to come out with newer hardware that happens to have a core in it to handle just that.
Kristie, let me ask you a shotgun question. How concerned are you about security in your business?
Very concerned.
Very high concern.
High concern.
So that was a factor when you were evaluating?
Absolutely, 100%.
Very
Yeah, we stream content essentially from the user's home to a trainer offsite.
So that's critical. So if I was working out, I wouldn't want anybody to watch that, I guarantee it.
Yeah.
Any other questions from the audience? All right, I'd like to give each one of the folks on this panel, yeah, just go ahead and give them a hand, that's fine. I would, did anyone here have anything you just wanted to share and didn't get a chance to? Anybody?
No, Tim, I think you did a great job.
Yeah.
Well, thanks a million. It's great to be here. It was fun doing this. Thanks for your attention and good questions. Hope you enjoy the rest of your afternoon. Thank you.